This lecture explains the radiative zone. The learning goal is to be able to explain the radiative transfer that takes place in the radiative zone. The radiative zone of the sun surrounds the core and is surrounded by the convective zone. Recall the three processes by which energy flows. Conduction is the flow of energy due to two objects of different temperatures being in contact with each other. Because of conduction of heat, we put insulation on metal spoons or even an oven mitt when stirring pots of boiling water. Convection is the transport of material. Warm air masses and cold air masses are transported by convection. In a convection oven, air is heated one place and circulated to heat food. Forced hot air and forced hot water are both systems that use convection to provide heat to a room. Radiation is a flow of energy with light. In our everyday experience, the light is infrared or heat. When we stand in front of a bonfire on a cold autumn evening, we feel the radiation from the oxidizing fuel. If someone stands in front of us, the direct path of radiation is blocked because light travels in straight lines. We immediately feel cooler. Nuclear reactions take place only in the core of the sun. Two mechanisms are involved in the energy transport from the core to the surface: radiative transfer and convection. In the inner part of the sun, radiation is the primary mode of energy transport. This defines the sun's radiative zone. In the process called radiative transfer, energy moves from one place to another by the propagation of light. Note that the word radiation is also used to denote particles or electrons released in radioactive decay. A material that is transparent allows light to freely move, while one that is opaque prevents light from passing through. Opacity is the term used to describe how easily radiation can flow from the core to the surface of a star. The higher the opacity, the more difficult it is for radiation to flow. In the radiation zone, the opacity is low. The radiation zone is relatively transparent. However, the surrounding less dense and cooler convective zone is opaque. The processes of the convective zone are explained in the next lecture. Neutrinos produced in the sun's core propagate out of the sun without interacting with or scattering off other particles. In the radiative zone, photons do not simply propagate radially outward. Instead, they scatter off the particles, taking what is known as a random walk through the zone. Eventually, they walk into the convective zone, where they are convected to the surface of the sun. The distances between the interactions are so short, it can take gamma rays 100,000 years to find its way to the outer layers of the sun. The distribution of light wavelengths in different layers is based on the temperature of the layer and is described by Planck's law.